Welcome to Sujitra Statistics classes. Today we are going to discuss De Moivre's Laplace Theorem of normal distribution. That is normal distribution as a limiting form of binomial distribution. The theorem is as follows. A random variable follow binomial distribution with parameters n and p tends to normal as n becomes large provided neither p nor q is very small. That is, if x follows b and p for large n or limit n tends to infinity, x follows n np root npq. Or we can say that as normal distribution as a limiting form of binomial distribution. That is, as n tends to infinity, binomial tends to normal with the condition that neither p nor q is very small. We are going to prove this result. Given that x follows b n p, therefore f of x is ncx p raised x q raised n minus x. For x takes the value 0, 1, 2, etc. up to n equal to 0 elsewhere. And q equal to 1 minus p. And mean of x is np and variance of x is npq. And moment generating function of x is q plus p e raised to t all raised to n. Define z equal to x minus e of x divided by root of variance of x. That is equal to x minus np divided by root npq. Now let us write the moment generating function of z. mzt is equal to m of x minus mp divided by root npq t, which is equal to this. We can rewrite as by the property of moment generating function m x minus a by bt equal to expectation of e raised to t into x minus a by b. That is, in the place of x we have this one is equal to expectation of e raised to tx by b minus at by b. That is expectation of e raised to tx by b into e raised to minus at by b. And we know that expectation of ax is equal to a into expectation of x. Here e raised to minus at by b a constant, so we can take it outside. E raised to minus at by b into expectation of e raised to t by b x, which is equal to e raised to minus at by b into, this is, we can rewrite as mx t by b. Here a is equal to np and b equal to root npq. Therefore, we have e raised to minus npt divided by root of npq into mx t by root npq. So this is equal to e raised minus npt divided by root npq into x is a binomial variate, so moment generating function is q plus p raised to t all raised to n. So we can write instead of t this expression, that is q plus p e raised to t by root npq all raised to n. That is mzt is e raised minus npt by root npq into q plus p e raised t by root npq all raised to n. Taking logarithms on both sides, we have log mzt equal to log e raised minus npt divided by root npq into q plus p e raised t divided by root npq all raised to n. Log e raised minus npt divided by root npq plus n log q plus p e raised t by root npq log e raised minus npt divided by root npq plus n log q plus p e raised t divided by root npq. This log and e get cancelled. We have minus npt divided by root npq plus n log q plus p. We are going to expand e raised t by root npq in the following manner. We know that e raised x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus etc. Therefore, e raised t by root npq is equal to 1 plus t by root npq by 1 factorial plus t by root npq whole square by 2 factorial plus etc. That is equal to 1 plus t by root npq plus here 2 factorial is 2 and t by root npq is t square divided by npq. So we can write t square divided by 2 npq plus etc. Let us substitute this in the place of this expression. We have 1 plus t by root npq plus t square by 2 npq plus etc. That is minus npt divided by root npq plus n log q plus, remove this bracket, p plus, again write p into t by root npq plus t t square by 2 npq plus etc. This q plus p is 1. We know that q plus p equal to 1. So we can rewrite this as minus npt divided by root npq plus n log 1 plus p into t by root npq plus t square by 2 npq plus etc. Which is equal to minus npt divided by root npq plus n into. We are going to expand in the form of log 1 plus x is equal to x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus etc. So instead of this x we have p into this expression. Therefore we can write n into, instead of x we can write p into t by root npq plus t square by 2 npq plus etc. minus x square is p square into t by root npq plus t square by 2 npq plus etc. whole square divided by 2 plus etc. which is equal to minus npt divided by root npq plus n into pt by root npq plus pt square by 2 npq plus etc. minus p square by 2 into, what we are going to do with this t by root npq plus t square by 2 npq plus etc. whole square as a plus b plus etc. whole square. A square plus b square plus c square plus etc. plus 2ab plus 2ac plus 2bc plus etc. Therefore, t by root npq plus t square by 2 npq plus etc. whole square becomes t square by npq plus t raised to 4 by 4n square p square q square plus etc. Plus, let us think about 2ab, 2 into t square t cube by root npq into npq is 2 into npq raised to 3 by 2 plus etc. So, here we have n raised to 3 by 2 and here we have n square. So, n raised to 3 by 2 is less than n square. So, we are going to rewrite this as t square by npq plus order of terms containing n raised to 3 by 2. This is called order of term containing 1 by n raised to 3 by 2 and more. That is, this expression is changed to t square by npq plus order of term containing 1 by n raised to 3 by 2. This is for convenience. So, let us write this one here as t square by npq plus order of term containing 1 by n raised to 3 by 2. Which is equal to minus npt divided by root npq plus remove the bracket npt by root npq plus npt square by 2npq minus this one np square by 2 into t square by npq plus np square by 2 into order of term containing 1 by n raised to 3 by 2. And these two terms cancels each other. This np and this p, np get cancelled, n get cancelled, one p cancelled. So we have here t square by 2q, here minus pt square by 2q plus, what happened to this one? N divided by n raised to 3 by 2. N raised to 1 minus 3 by 2. That is n raised to minus 1 by 2 or 1 by n raised to 1 by 2. So we can rewrite this as order of term containing n raised to 1 by 2 and more. So we can rewrite this as order of term containing 1 by n raised to 1 by 2. Now let us take t square by 2q outside. We have 1 minus p plus order of term containing 1 by n raised to 1 by 2. That 1 minus p, we know that 1 minus p is q. So, t square by 2q into q plus order of term containing 1 by n raised to 1 by 2, that is t square by 2 plus order of term containing 1 by n raised to 1 by 2. As n tends to infinity, order of term containing 1 by n raised to 1 by 2 tends to 0. As n tends to infinity, log mzt is equal to t square by 2. Removing the logarithms, we can rewrite this as mzt is equal to e raised to t square by 2. And what is e raised to t square by 2? Is the moment generating function of a standard normal variable, that is n01. Therefore, by the uniqueness theorem, we can say that Z, that is x minus np by root npq, follows n01. That is, x follows a normal distribution with mean NP and standard deviation NPQ when n is large. Therefore, binomial distribution tends to normal distribution. Thank you. Thank you for patient listening.